Hello, this is Miss Moore, and today during chemistry we're going to discuss titrations. Today's essential question, what is a titration and how are titration calculations done? For today's lecture you should have your calculators and periodic tables and polyatomic ion handouts handy. Neutralization reactions. A titration reaction is a reaction in which an acid and a base are neutralized. A titration reaction is also known as a neutralization reaction. And you guys are familiar with that. An acid plus a base produce water and salt. So the first step in a titration reaction calculation is to complete and balance the neutralization reaction. All right, here we go with titrations. So the concentration of an acid or a base in solution can be determined by performing a neutralization reaction. So we can do a reaction to figure out the concentration of an unknown concentration of an acid or a base. So the steps to do a titration reaction, a titration or a neutralization reaction. Okay, so right now I'm not talking about what you would do with a piece of paper and a pencil. I'm talking about a real reaction, okay? So a measured volume, meaning a certain amount, of an acid solution of unknown concentration is added to a flask or a beaker. Then several drops of a pH indicator is added to the acid solution. A pH indicator will tell you the pH of the solution. Then small measured volumes of a base of known concentration. And because this is a known concentration, this is called the standard solution, are mixed into the acid until the indicator changes color. The reaction is complete when equivalence point has been reached. Important term there. So what is equivalence point? It's the point at which the amount of hydroxide ions, OH1 minus, equals the amount of hydronium ions. And if you remember, a lot of those would indicate a basic solution. A lot of those would indicate an acid solution. If they're equal, the solution is neutral. All right, so now titration calculations. This is what you would do using a pencil and a piece of paper and probably a calculator. All right. So for titration calculations, we're going to use a combination of stoichiometry and molarity calculations using molarity equals mole divided by liter. So the first thing you're going to do is write and balance a neutralization reaction. Okay, you're given the acid and the base, so you need to figure out, one of the products is water, you figure out the salt, you balance the equation because you need the balance equation to do stoichiometry. Okay? Then read the problem, make a list of the information given for the acid and the base, stare at that information for a while until you come up with a plan on how to find your unknown, and then do the calculations. All right, let's try a titration calculation. So, question. Calculate the volume of 0.256 molar barium hydroxide needed to neutralize 46 milliliters of 0.407 molar chloric acid. All right, so the first thing we need to do is write the neutralization reaction. We'll start with the acid, which is chloric acid. Because it's an acid, we know it's going to start with an H1 plus. It's chloric, which means it's chlorate. So chlorate is ClO3, 1 minus, and those guys are neutral. Our base is barium hydroxide. So barium is a 2 plus. Hydroxide is OH, 1 minus. So to neutralize those, we need 2 hydroxides. And that's going to produce a water and some salt. Remember, the salt comes from the cation from the base and the anion from the acid. So we're going to have Ba, which is a 2 plus ClO3, 2. See if I can get that to show up, 2. All right, so now to balance this, we're going to put a 2 here and a 2 here, and now it's balanced. All right, the next step is let's make a list of what we know. So they talk about barium hydroxide, and they talk about chloric acid. So let's see what kind of information they give us. So we're going to calculate the volume of barium hydroxide. So our volume is going to be X. They tell us we have the molarity is 0.256, and instead of writing molar, I'm going to write mole over liter because we're going to be doing some calculations at some point. All right, what else do they tell us? If we now go to the chloric acid, they tell us we have a volume of 46 milliliters, and we have a molarity of 0.407 mole per liter. All right, so what can we do from here? Well, what we have is we have volume and molarity. So it looks like we're going to be using the formula molarity equals mole over liters. And we don't have enough information for the base BaOH2, but we do have enough information for chloric acid to solve for N. So let's do that. So again, using the formula molarity equals mole over liter, let's plug in what we've got. We have a molarity of 0.407 mole over liter equals, we don't know the number of moles. Our volume right now is in milliliters. We need to make that liters. And now we'll cross multiply and solve for X. And that gave me an N of 0.019 mole, keep taking into account sig figs. All right, so let's put that information here. Now, we're trying to get to volume of barium hydroxide. So with the information we have now, I would suggest doing a stoichiometry problem and figuring out, since we know the moles of barium hydroxide, we can figure out the number of moles of chloric acid, and then we can solve for the volume. So let's try that. All right, so we know we have 0.019 mole of HClO3, and we want to know what that is, how many moles of barium hydroxide that'll give us. So we'll set up our grid. Put the given over 1. Now, to convert from mole of one thing to mole of the other, we're going to use the mole-mole ratio from the balanced equation. And we're interested in this guy and this guy. So we will have 2 mole, except for somebody could tell me I wrote this wrong, 0.019. So now we have 2 mole HClO3 and 1 mole BaOH2. Those cross out. And so when we do the math, we come up with 0.0095 mole. All right, so we did all of that work to calculate the volume of BaOH2, and we now have enough information to do that. Again, we're going to use molarity equals mole over liter, so we're going to have 0.256 mole over liter equals 0.0095 mole. Let's try that again. 0.0095 mole over X. And we'll cross multiply and solve for X. And that gave me 0.037 liters. And if we would like to change that to milliliters, we would have 37 milliliters. So, how much barium hydroxide is needed to neutralize 46 milliliters of chloric acid, of 0.407 molarity chloric acid? 37 milliliters. All right, let's try one more practice problem. A student titrates a 20 milliliter sample of a solution of HBr with an unknown molarity. That titration requires 20.05 milliliters of a 0.1819 molar solution of NaOH. What is the molarity of the HBr solution? Okay, well, I'll give you the answer, and you can work it out on your own. 0.1824 molar HBr. Okay, have a good one.